Hi, I'm Susan Forney from Hurricane Electric, and today I'm here to talk about some observations I made about IPv6 adoption over internet exchanges. And I started this talk out with a pro IPv6 disclaimer just to make sure you know where our politics are. Hurricane Electric has worked to advance IPv6 deployments globally, pretty much most of its existence. We got our first IPv6 allocation in 2001. Our network completed a native IPv6 conversion in 2007. And we peer with more autonomous systems over IPv6 than any other network. As of today, it was 5,409. If you're into trivia, we also peer with 8,507 ASNs over IPv4, which also is more than any other ISP. So let's look at how these European internet exchanges have progressed in the adoption of IPv6. I made a couple of assumptions when I did this talk. The first one was that internet exchanges historically are where we grow the internet, and that increasing IPv6 traffic across exchanges would logically start with increasing IPv6 peering. So given those things, I noticed that first, behavior in European exchanges shapes the industry. And this has been true pretty much since the beginning of the internet. You can do things on internet exchanges that you just can't do from transit providers. They can adapt more quickly. It's a place where you can experiment with things between networks, and it provides a service that ISPs just can't. So that's the reason why I think so many, so much of the things that we want to accomplish in the industry and get things off the ground tend to happen at the IXs first. A few things to keep in mind are that 27.3% of all networks advertise IPv6 prefixes. And there are 740 internet exchanges globally, including 5 new internet exchanges that cropped up this year in the middle of a pandemic, which shows you that they're not going out of style. And of those 740 internet exchanges, 462 of them are in Europe. So, the large bulk of the internet exchanges are right here in Europe. Europe hosts 7 of the top internet exchanges in the world if you measure them by members. And peers are more likely to have both an IPv4 and an IPv6 peering session on a European exchange than they are on other exchanges in the world. So the next thing I decided to look at was, how many what our top European exchanges were by members, and these are the ones I'm going to start looking at as far as the statistics go. The first one is. Oh, I'm sorry, I got a slide ahead of myself there. The first one is DKIX Frankfurt, which has about a little over 1,000 members. The second one is AMSIX with about 951. Lynx has about 837 members. Data IX has about 661. EPIX Katowice has 528. Moscow IX 485. The Netherlands has 430. France IX has about 424, and coming in with about 398 is Equinix Paris. So those are the top exchanges by members. So when I first thought about doing this talk, I thought that it would be interesting to measure how many exchanges had IPv6 addresses, but I quickly realized that if you look at this slide, that if I just went by the number of IPv6 assigned addresses, that might not be so accurate, because a lot of people have more IPv6 addresses than IPv4 because there are more of them. And so then I thought, well, maybe the best way to measure this would just be to go by how many assigned IPv6 addresses there were per assigned IPv4, because at most internet exchanges, people will have at least one of each, and that might be a good way to compare them. Because there are more IPv6 addresses than IPv4, though, you can see in this graph that we did a little bit better. Like, for instance, in Katowice and Equinix Paris, they actually have more than 100% of IPv6 addresses per IPv4, because they have people with multiple IPv6 addresses and not multiple IPv4 addresses. DKIX, Frankfurt, France IX, Data IX, and Moscow IX, those all had about 100% of, for every IPv4 address, they had an IPv6 address. And then Moscow IX and EPIX Warsaw were really close. Links was about 87% after that. And I think that the lowest one was 80%, if I remember my numbers right. So, that was pretty good. IPv4 addresses for IPv6, that's looking pretty good. But then I thought, well, it's probably not enough just to assume that just because everyone has an IPv6 address that they're peering over it. I know for a fact at many exchanges that this is not true when I attempt to peer with somebody who has an IPv6 address, and they'll tell me, oh no, we're just not peering on that. So then I thought, well, how do I look at this? And then I thought, well, if you can ping that address, it's assigned on the interface, that's a pretty good sign that that person wants to peer on the exchange. So let's take a look at that. And that's what I did. So then I looked at the reachable IPv6 addresses at the top of internet exchanges. And when you put those in the orange bars right next to the blue one, you get a completely different picture than we had before. So you can see that most of the, at none of the internet exchanges do we have 100% IPv6 reachable. But we have some that are better than others. Obviously, coming in first place here is the Links Juniper LAN, and coming in last place is EPIX Warsaw, which only has about 11%. But that was a lot of disparity about which ones had available IP addresses and which ones didn't. So then I thought, well, it does look like we might need to see some improvement in IPv6 peering. But, the big exchanges, they have a lot of members in them. People come and go. Things don't get cleaned up. I thought, well, maybe if I looked at some of the smaller exchanges to see what the trends were there, that might be interesting. So then I decided I'd look at some smaller ones. And I picked our friends in Finland and NetIX, INEX in Dublin, UAIX, SpeedIX, SwissIX, DKIX in Berlin, NIX, DKIX Madrid, and I can't see the last part of this last slide here. The video link is covering it. Looks like AM6. So then then I went back and I compared those as well, and then what we see is that we've got a great disparity again. The lower ones are like UAIX and NetIX. Even Finland, that was kind of shocking because those guys are so on top of it, was a little bit lower. And BKIX and SwissIX and Nix.cz were all doing pretty well as far as IPv6 spaces that were assigned. So then I thought, okay, what happens if I look at IP address spaces in UK and Ireland, so we can bring it a little bit closer to home? And so I decided to look at Link Manchester, Link Scotland, LoanApp, Equinix London, IX Leeds, and then Links again and INEX, just to put everybody into perspective. And then let's look at their IPv6 utilization. Well, we are, if we look at who is doing the best, you can see that Links Manchester and Links Scotland and Links are all doing very well as far as, and actually I have to apologize here because this IX Leeds bar is actually not accurate. This is actually supposed to be 96%. Now it looks like I've transposed the numbers to 69%, but actually IX leads is has the largest number of reachable IPv6 addresses in all of these internet exchanges in the UK and Ireland. But as you can see, for the most part, the numbers are pretty even across this region. It's better than 50% most of the places, and it looks like adoption there is doing pretty well.
Susan, if I may just interject quickly, just
Yes.
to let you know, you've got about 9 minutes left speaking time.
Oh yeah, don't worry, we'll be okay.
Just to let you know.
So then I decided that I would rank all of the IPv6 and reachable addresses for all the IXs that we looked at. And again, as I said, this is the reason why I wanted to correct the IX links, that leads bar, because leads turned out to be by far in this region the best number of reachable IPv6 addresses on its IX. And then you can see it's NLIX, BKIX, Links, Juniperland, NIX, CZ, DKIX Frankfurt, Equinix Paris, AMSIX, SpeedIX, SwissIX, INX. So you could go all the way down there, but you can see that, and then of course, bringing up the rear is EPIX Katowice. But you can see that across Europe that pretty much most of the exchanges, if we look at those graphs, most of those exchanges are above 50%. And the bulk of them are above above 70%. So honestly, in the region, that's not too bad for reachable IPv6 addresses and the ability to peer. And then I did think about why we saw some of the disparities that we did, where some of the exchanges were not as populated as the other ones. And I did another talk about internet penetration in countries. And I took the slide from that talk here to kind of demonstrate what I saw. And what you can see is that, like in countries like in Netherlands and Germany, the percentage of the population that are internet users are very high. And in places like Bulgaria and Poland, and at the end of the chart, those are lower. And there was a direct correlation between the percentage of the population that was internet users and the number of places that had deployed IPv6. And that's kind of obvious if you stop and think about it, because the IPv6 is, for if you're just deploying the internet and trying to get people out there, obviously you don't have to have it. You have to have IPv4. And so most of the developing places will deploy IPv4 first. And then the places that had internet for a long time and are having, struggling to, keep everybody on, get addresses, that really need IPv6, those will be in the places, and tend to be in the places where there is a higher percentage of penetration of the internet. And so you see that in the Netherlands, where, things are very, very, that their population is very, very saturated. And also, it also means that that IPv6 is, pretty viable, because, that's really important for those populations. So that was the reason why I stuck that slide in there. So these figures basically show you that, you can assign an IPv6 address to people, but you just can't make them peer. But based on what we just saw, I thought a few assumptions were reasonable. First, IPv6 routing is actively encouraged on European exchanges. We can see that by the bulk of the exchanges having reachable IPv6 addresses. So it's alive and well. The second thing is that a large percentage of European networks are routing IPv6. And the number is higher than the global average of 27.3% of all ASNs is what we looked at. And actually, I did average all of those reachable addresses, and I came up with, it was 56.4. So almost literally double what the global average is. So that is really pretty impressive for Europe. The IPv6 deployment is healthy there. And if the network isn't peering over IPv6, it's probably because it hasn't deployed it. So this is important because, as we know, last year, Rife distributed its last 22. and Aaron and Lacnic, of course, are also exhausted. You can use NAT to get around not needing IPv6, but CGN still requires additional IP spaces. Can't make one IP last forever, and so sooner or later you're going to need more IPv4. And you can, even though you can't get it from IRR so much anymore, you can still buy it. But I believe that last I checked, pricing was about 21 euros per IP, and it's expected to double. So it's not getting any cheaper. And then IPv4 transactions are increasing year over year as RIRs exhaust their allocation. And what I have here is a quick little chart to look at to see how that works. And what you can see is that the blue line that is peaking up really far to the right is Aaron, and the gray one is ripe, the first two to exhaust. And there's a peak in 2015 that is a change of policy in ripe that made it peak in that year, so it's not related to the IPv4. But you can see the trajectory with Aaron, which didn't have the policy change. As soon as Aaron ran out, it started the amount of IPv4 address transfers, in other words, shuffling IP addresses around so that more people could have them because they were scarce, went way up, and it has continued to go up in ripe as well. So it's very obvious that things are scarce and it's not getting any better. So the increasing number of transactions reflects demand, and of course, demand is it's a reflection of the rising price of IPv4 and the scarcity of it. And the available of IPv4 addresses, pretty soon, the only way you're going to be able to get them is through a broker. So as more users are added to the internet, the demand for IPv4 is just going to rise. And the marketing and transfers of legacy IPv4 blocks means that most networks are probably going to be able to get IPv4 in the first term, in the short term, and demand and speculation is going to put some pressure on the price. It's obvious that more peering on the internet exchanges is going to drive more IPv6 deployment. But what might not be as obvious is that encouraging the growth of IPv4 networks actually works in favor even of the people who want to stay on IPv4. Because when more traffic moves to IPv6, it lessens the demand for IPv4. And when networks don't deploy on IPv6, they put pressure on the IPv4 supply, which increases prices and the cost of operating networks. So what I am saying here is that whether you are pro IPv6 or you just want to stay on IPv4 and have everyone else leave you alone, that the best thing to do is to encourage everyone to deploy IPv6. Now, if you think more networks need to route traffic over IPv6, there is something actually that you can do about it. First, when you peer and you turn up those sessions, make sure you turn up IPv6 sessions with the IPv4 sessions. And then advertise your IPv6 prefixes and ask the other networks to advertise theirs. Lots of times I turn up interfaces with peers and I don't see them advertise any prefixes to me. And I know a lot of you are going to say, well, that's Susan, that's because we just wanted to turn them up on a maintenance window. We don't want to turn it up, right? We just get the peer up and we'll add the addresses later. That's valid. But when 6 months later, I still see that you have not turned up your IPv, or you have not started advertising IPv6 prefixes, then I start to worry. So it's always a good idea to ask people, maybe they've just forgot, but go out there and poke them. And then check back with your IPv4 only neighbors from time to time to see if they've added IPv6 peering. That's how we keep this going, make sure everybody knows we're interested, keep up the pressure, and make people want to peer over IPv6. So in summary, IPv6 participation on Europeans' internet exchanges is better than the global average and is better than just about any place else in the world. And while IPv6 adoption continues to increase, it looks like IPv4 is here for the foreseeable future. I actually saw somebody who said that they thought that we'd be dual stacking IPv4 and IPv6 until 2045, and I really hope they're wrong. And then no matter what your politics are, increasing peering over IPv6 is going to help you meet your objectives rather. And so at that point, I think I'm done. Thank you. Do you have any questions?
Thank you very much, Susan. There are no questions at the moment. Might give it a moment in case somebody's frantically typing one as we speak. While we're waiting, I'm not sure if I'm allowed to ask a question, but I will anyway, because I've got the chair. The getting off the dual stack is a challenge. I mean, I think you're encouraging people to get onto dual stack, get v6 lit up, but what's the next step to get off dual stack? That's going to be a tough call, isn't it, in the future? Hopefully not 2045, but it's going to be a tough move when we come to it.
Yeah, that is a tough call, but getting off of v6 is, you know, I am a believer of if you build it, they will come. And also, if it's really crowded, you know, if it's really crowded in one spot, people will move to the place where it's less crowded. And so, and if you get the IPv6 up, and you know, the majority of the websites, you know, the major websites in the world have an IPv6 site. You know, I think it's up to 96% now. There's a page on bgp.he.net that documents that. And so because of that, you know, you realize that most of the major players have adopted IPv6. A lot of the major players like AT&T and T-Mobile have IPv6 only for their cellular clients, and a lot of the the eyeball networks, you know, in the United States, Comcast is a big one. They have adopted IPv6 to all of their end users. So, you know, a lot of the users right now are on IPv6 by default and have to use, you know, 6-to-4 translation services just to access anything that isn't on v6. So, you know, that definitely is happening. But the more things that the more network that we put out there on IPv6 and make sure that everybody gets on the protocol, that's how you're going to get them to adopt it, and how you're going to be able to get off IPv6 altogether. You know, a relative of mine, Pete Stevens at Mythic Beasts, has, you know, an entire hosting service that he does everything over IPv6, and he doesn't have IPv4. And you know, everybody is living happily ever after.
Wow, that's you'll see in the future then. Thanks very much, Susan. There are no other questions, so I guess we'll hand back there.